In the next two problems, I've asked us to simplify, but I've been very explicit by what I mean in this case by simplifying, because it's not always clear sometimes whether this version or that version of something is simpler. We're going to simplify by canceling whatever we can. So anytime I have a fraction with the same thing on top and on bottom, I can cancel that. Okay? It's understood, of course, that my expression is only equal to what I get if what I canceled isn't 0. Okay? And then we're going to write the final answer without fractions. That bit of the directions is going to be helpful so that we all end up with the same answer, because there are so many equivalent ways of writing trig expressions with these trig identities. Now, if I look at this first problem, it happens to be number 24 from your text. It doesn't look at first like anything cancels, because I see sine x on top and I don't see any sines on the bottom. But very often with trig functions, there's cancellation that you can do that's sort of disguised. What I find it really helpful to do to see if there are any things that cancel that aren't super obvious is to write everything in terms of just sine and cosine. Because with the reciprocal and the quotient identities, every trig function can be written in terms of just sines and cosines. So the top is sine x. I'm going to keep that as is. On bottom, I'm going to rewrite secant of x as the reciprocal of cosine of x. And then I'm going to rewrite cotangent of x as cosine of x. Whoops. Cosine of x over sine of x. Okay, excellent. So now I can see that there is some cancellation, because on bottom I can cancel those cosines. Now, of course, this is only going to work if cosine is not 0. Your book doesn't actually have you writing out those restrictions, and so I'm not going to insist that you do, but you want to sort of make a mental note as you're doing things. Anytime you're canceling something, this thing is only equal to that thing if both sides are defined. Okay, so now we've got sine x divided by 1 over sine x. Okay. And, well, when I divide by a fraction, I would multiply by the reciprocal. So this would be sine x times sine x over 1, and that would just be sine squared of x. Now that does look a lot simpler than what we have right here. Okay. So in order to get to here, we made it look a lot more complicated, because we wrote this as a complex fraction. But often by writing things in terms of sines and cosines, you're going to find some things that you can cancel that were sort of disguised by using all 6 trig functions instead of just those 2. Okay. So here, I don't even have a fraction at first, but there is going to be some stuff that cancels. I want you to try number 25. This is one of the assigned problems from the homework, so pause the video and try that. You're getting a head start on the homework when you do that. With this one, you might have noticed that tangent and cotangent are reciprocals of each other. So one of these copies of tangent is going to cancel with the cotangent. But I think even so, I'm going to rewrite this whole thing just in terms of sines and cosines. So tangent squared, I'm going to write that as sine squared x over cosine squared x, times cotangent, I'm going to write that as cosine of x over sine x. And then cosecant, I'll write that as 1 over sine x. Now it's a little easier to see what's going to cancel. Okay, so I can cancel this cosine with one of those cosines. So I've got one factor of cosine left on the bottom. I can cancel this sine with one of those sines. Okay, and that really is my cotangent canceling out one of the factors of tangent that we had. Okay. But then I still have a sine on bottom here. I can cancel that with that other sine. So it looks like what we're left with on top is that canceled, that canceled, that was just 1 over, we have a single factor of cosine of x. And they asked us to write our answer without fractions. So now I would use that reciprocal identity again to rewrite that as secant of x. So that trick of writing things in terms of sines and cosines is often really, really helpful. When I'm trying to prove a trig identity, which is what we're building up to, If I don't see what else to do, that's my go-to. I write everything in terms of just those two trig functions.